Video we're going to talk about regression errors, SSR, SST, and SSE. I'm going to use an example that your homework, Spotify, you bad app. I hate it when it does that. We will talk about, where was I? We're going to use an example that is on your homework in the Chapter 4 quiz so you can follow along and make sure your homework's done correctly. I don't normally show you step-by-step how to complete your homework, but in this case, I felt it was good so you could have an example that you were working with right in front of you while I'm rambling on. For problems 10 through 4, let's just ignore the fact that we have the problems, and I'm going to go and talk about each one and then relate it to the problem. So R squared, SSE, SSR, and SST, what are they and what do they do? What do they mean? Well, what are they? These are statistics that try to find out how much a variable contributes to the overall correlation. Easier said than done. R squared is called the coefficient of determination. It is the function, its function is to indicate how much variability is in the y value, which means if r squared is 0.9474, then the y variable contributes about 94% above other variables to the relationship. If r squared equals 1, then 100% of the relationship is based on the y values, and the two things that you are comparing are directly related. R squared also tells us how good wow, I can speak English. R squared also tells us how good our line of best fit is. I apparently can't type, and I should probably proofread. The closer to 1, the stronger the line. But now let's break it down. All right, when we run a regression analysis and find the line of best fit, we will always have data points not on that line. The data points will occur either above or below. I'm going to use the example for violent crime from Chapter 4 quiz, and this is what I'm talking about right here. These guys are above, these guys are below, and we have to calculate numbers to tell us how much distance is here. I mean, we can look at it and guess, but that's not what we do here. We use numbers to make it happen. This is our data that made this chart. This is our line of best fit. As you can see, there's a positive correlation, which you also should have known when you were asked to find it in number 8 and 9. So you were asked to compute that, and then I'll show you how to do that too. I never showed that in the video, but I'll show you that. And yes, and this is your scatter plot from number 7. So 7, 8, and 9 right here. Okay. So let's talk about the sum of square errors. These tell us how much our prediction is going to be off in general. Like basically it's going to be off, like it's this, give or take a few points. But that's really annoying to calculate by hand. If you look in the chapters, which I'm sure some of you did, and looked at the equations and went, what the crap? We only have 3:41 in this video. I hate the 5-minute limit, by the way. I can ramble on like the best of them. All right, so I'm going to go to my violent crime spreadsheet. And here I've done my R equation, which is the equals Correll, the B2 to B13. I have all my data. Now I did my scatter plot, and to get the line of best fit, I click on the dots, right-click, go to Add Trend Line, and I can click Display Equation on Chart and display R squared value on chart, which we will do later on in the videos. So I have the equation and the trend line already there, so I'm going to close this off. So the first thing we need to do when calculating our SSE is we need to take what our predicted rate is. So what I did is I took my formula from here and programmed Excel to take my X values, or my 2002 values, and crank out what it thinks will be our Y value. Okay, so I typed in 0.745 B2 because my column is going to be, my data is going to run from B2 to B13, plus my 2.0373, and then I dragged and dropped. Oops. I dragged and dropped. All right. Now, of course, I also did that. my correlation. Now I need to calculate my residual, and this comes into number 14 on the problems. Find the prediction error for the following percentages, which is going to be the residual, which is the formula is on page 197, and it is the 6th bullet point down, which is saying y minus y hat. This is y hat. These are your y hats. Here is your residual, so your answer for number 14 relies in this column that I'm going to show you how to do. In this box, I need to take the difference between the y value and the predicted rate. So C2 minus E2, drag and drop. Gives you the residual for everything. So on number 14, 7.9, the residual for 7.9, your answer should be 0.05. Okay? Now, we need to square this guy. So I'm going to type in equals my data squared. Now to square something, you do the little caret to the square. All right? And then to get your SSE is the sum of all those squares, so you just sum it up with equals equals your data for the sum. And your standard error, or little s, and this is where notation gets confusing because we also use little s for standard deviation. Our standard error, little s, is this number is this guy divided by n minus 2, because you have 12 data points, so I put 10 in there. And the square root. When you type in square root, it's SQRT. Okay, so that is your SSE. Now, let's talk about what SST means. If I can get to my PowerPoint. Here we go. So, SST is the total, I should make this bigger, is the total sum of errors. It tells us how much our prediction is, I can read. SST is the total sum of squares, wow. Of squares, I can proofread. This tells us the total variability in the y values and how much do the y values vary from the mean of the y values. And you need the mean of the y values. So let's go back to our Excel form. I have an entire sheet done for this already. So here's all our y values. Here's our y mean, done with the average. This guy, the SST, am I on SST? It's so hard to tell the difference between these two. Yes, I'm on SST. So the SST relies on subtracting the y value minus the y mean. Okay, so that's what all of those are. And then this is the square. Y minus y mean squared. Okay, so I typed into Excel equals A1, because that's where my data goes, minus, and I locked in this number with dollar signs so it doesn't change when I pull it down. And then I squared them. So I just took this, raised it to the 2, and dragged it down again, and then found the sum, and you have your SST. And your SSR, or SSD, I don't know why it's D, it should be SSR. Sorry. All right, so sum of squares regression. This measures the amount of improvement in the accuracy of our estimates when using the regression equation compared with relying only on the y values and ignoring our x values. That's a whole mouthful. But anyway, these numbers are going to give us our r squared, but Excel does it for us. Speaking of Excel, open sesame. So I even did an Excel sheet on SSR. So this is our predicted. So what I did is I copied and pasted it from our predicted rate here, because it's our predicted rate subtracted by our y mean squared. So instead of doing 3 columns this time, I got a little fancy with my Excel formulas. I also copied my y mean over, but that looks different than my y mean over here. Why? What did I do? Did I calculate the wrong mean? Oh, this is a formula. This should not be a formula. This should just actually be my y mean. and that's the round sheet, so it should be 325, 8.325. 8.325. All right, that changes the values a little bit. Did that change? Yes. All right, so what I did is I set Excel to equal the A column subtracted by the fixed B, and I just put those in parentheses to square the whole value, and then dragged and dropped, okay, and then summed it up. And that's our SSR. Hopefully you can follow this. At least you can pause the video to see what I've typed in. I did it on 3 separate spreadsheets in order to make it easier to compartmentalize what I'm doing. And it's not acceptable just to copy my answers down for problem 10. I do want you to actually try this and make sure that you can manipulate Excel correctly. So let's talk a little bit more about relationships. So SST, the total sum of the squares, is going to equal your SSR plus your SSE. And your R squared is your SSR over your SST, but we can do R2 in Excel. Super, super easy. We're going to go back to our linear regression scatter plot, which is right here. And I'm going to click on a dot, and I'm going to right click. I'm going to go to add trend line and click display R squared value on chart. So this is saying that about 86% of the monthly crimes in 2004 are directly related to the monthly crimes in 2002. Okay, but there are other factors involved, about 14% other factors involved in the crime rate of 2004. Okay, so hopefully that will help you along, and go me for doing it in under 4 videos. So I really hope that helps you understand what we're doing and what these problems are asking, and try and do it yourself. What I'm looking for, what I want from you from this lesson, was to be able to construct the scatter plot, to be able to calculate a line of best fit, to be able to figure out what your R was, and to let me know if it's to be able to know the difference between positive and negative correlations. Not so much on R squared, but it is important to know how good our estimate is, and that's what R squared is. As for you calculating your standard errors, I will probably never ask you for that again. But for the purposes of the assignment, I would like you to at least try the math and submit it to me whenever you can. Thank you. Have a great rest of your weekend or week or whatever time you are watching this video.